So we just do a little bit in class, and the rest you can always do later at home. Maybe we'll do the other investigation together because of the time. It's already on the module. So if you have completed that, please go on Ed module, because there's one more investigation, but this time around we're going to do it together. If you have completed A and D especially, or A and C, you don't have to do all the 4, please. We have 7 minutes to launch. So go on Ed module. I call that activity 5, and it's an investigation into the reciprocal of nonlinear functions. Okay, so can we please look at the board? Let's look at the board. All right, so if you look at the worksheet online, this time around we want to look at what the graph will look like for 1 over f of x if f of x itself is nonlinear. Linear is easy. 3 things. I wrote 2 there, so please make sure you note the 3rd one. Lillian mentioned something that will make life easier the other time. That the line and the inverse always are in the same quadrant. Okay? So apart from the asymptote that we talked about, you always look at their quadrants. Okay? So please, you take note of that when I give you the summary that I've typed out for you. Alright. But in this case, it will be different a little bit. So let's see. Everybody, let's go to decimals again. So we're going to just do the first one and the last one. Instead of the first one, because x squared just touches the origin, right? So maybe we could look at, we could do 3. So I'm going to pick number 1. So plot number 1, number 4, number 4, and maybe number 5. Number 1 and 2 are similar. So you can see that there are 2 transformations in 1 and 2, isn't it? So if we have this, we can actually talk about this too, isn't it? Okay? There's a translation, right? And there's a reflection. So we don't need to bother too much. So we can actually pick either of these 2. So maybe we just pick 1. We pick 4 and pick 5. So let's see. So if I plot 1, so that's x squared. And the other is 1 over x squared. Okay? So let's see what that does for us. Let's go to the other function. The other function is x minus 1, x minus 3. Please type this first. X minus 1, x, is it minus 3? Yes. X minus 1, x minus 3, yes. And the reciprocal of that. So I'm just going to copy this and paste it down here. So that's the second. Let's do the 3rd one. The 3rd one is the last question there. 1 over x plus 1 over x minus 1. That's number 6 on the board. Let's move again. So x slash, is it minus first? Plus first, then minus. But it doesn't matter anyway. Plus 1 here, x minus 1 here. Then the reverse, so we just copy this, paste, and we change the signs. Minus here, and plus here. So we're going to quickly look at these three functions. So let me hear your view first. We have just 3 minutes, please, at the end of the class. What are your observations? Check this out. That's the first one. Look at another one, and look at another one. How about we draw the asymptote also? Can we put the asymptote? So for this one, it will be x minus x is equal to 1 and x is equal to 3, right? That's one of them. Okay? And the y asymptote is always 0. You can see that it's 0 in this case, right? So let's just do x equals 1 and x equals 3. Okay? Those are the two vertical asymptotes. So in this case also, x equals what? X equals 1. And for the inverse, we have x equals negative 1. And for the y asymptote, we have 1 always. Y equals 1. Do you know why it is 1? Because either of these, if you break it into two functions, you have one whole number plus something over x plus 1. Or maybe something over x minus 1. So whether for the real function or for the other one, the horizontal asymptote is y is equal to 1. So which is this line? Does that make sense? And the vertical asymptote is different. So we will see the connections now. In this case, we don't have any vertical asymptote. Okay? For the original function. For the inverse, it is what? X is equal to 0. And that's clear because at 0 it is undefined. Okay? And of course the horizontal still remain y is equal to 0. So now what do we notice? Yes, observations please. There is something we can observe here. One of them is the fact that the solutions of the original functions are the vertical asymptote of the inverse. Okay? The solution of the original function are the vertical asymptote of the inverse. Do we notice that? Yes. So let's see. Original function here, the solution is x is equal to negative 1. Right? The original function is red. Does it have a solution? Yes, it crosses here. Can you see? The solution is here. This point. Can everybody see that? And that's where the vertical asymptote for the reciprocal, which is in blue. Hello? Okay? So that works. Another thing we can notice here is that the turning point of the original function in red, the minimum, is as long as that point is not the solution. Which means when you have a case where you have x squared, like this, in this case, it doesn't work, what I'm about to say. Because your local minimum point is also the solution, so that doesn't work in this case. But in this case, it is not the solution. The local minimum is not the solution. And that becomes the local maximum of the inverse as well. Okay? If the local minimum exists, and that local minimum is not the solution, it automatically becomes the local maximum, the opposite way of the inverse. If it happens to be if this happens to be negative, so we put negative here to make it an inverse function, and put negative here. Let's see. Can you see the same thing happens? For the original function, the local maximum happens to be the local minimum of the inverse graph, as long as that point is not the solution. Okay? What other thing can we see here? What about the behavior as the function? When this function tends to infinity, when f of x tends to infinity, what happens to the inverse? Because this will tend to infinity when x becomes large, right? What happens to the inverse is coming close to 0 as x becomes large. So as this function tends to infinity, the reciprocal becomes close to 0. When I say the function, I mean the y value now. Does that make sense? And look at the other side. As it tends to negative infinity, this also comes to 0. Let's see if it happens to the others. In this case, as it comes to negative infinity, in this one, this is the positive infinity. Okay? This is the positive infinity. Because we are talking about the y value. Okay, so let's see here, as it tends to negative infinity, which means when x becomes so large, what happens to the reciprocal is also come to 0 from this side. So it works for either case. Am I making sense?
Yes.
Did I miss any points out? I'm going to give you all the points. So here I have noted 1, 2, 3, 4, 5. Yes, when f of x is greater than 0, the inverse is also greater than 0. Do we see that? And when it is less than 0, you see, when the function is less than 0, the y values, what happens to the y value of the reciprocal also? Less than 0. Can you see that? On both sides. Let's see the other one. Here, between here and here, what happens? This function is negative. Look at the red also, it's negative. When the blue is positive, this one is also positive. Do you understand that? The one of quadratic, this one, when the red is positive, y, the blue is also positive y. Even though we don't have a negative here, clearly because of the square. Okay? But the case where it doesn't, the square is not trivial, like this one, we could see. I'm going to delete that negative that made us change the way the function is. Let's see if we still have the same thing. Okay, and you see? Both are positive here. And within this range of values, the original function is negative. Within that same range of values, the inverse is negative. Does that make sense? Yeah. So these are the trivial behavior that we can see. What I will do is, I'm going to hold on to the last practice paper, which is on the inverse for nonlinear. We will talk about that tomorrow. Okay? So please pass this round quickly. Sorry, I delayed you a little bit. Yeah? Miss V?